This is Dr. Wood with Citadel Civil Engineering. This is CIVL202 Statics. And in this lecture, we're going to revisit vector addition, but now thinking about it in terms of 3 dimensions. So in this case, we're going to do exactly what we did when we had components in 2 dimensions. We're just going to expand that into 3 dimensions. So when thinking about 3D vector addition, we can start with our Cartesian vector notation. And in this case, we're going to say that the resultant force is going to be equal to the sum of some set of forces that would start with the sum of the forces in the x direction times the I unit vector plus the sum of the forces in the y direction times the j unit vector plus the sum of the forces in the z direction times the k unit vector. Now remember, this is not one equation, even though it looks like one line. It's actually got 3 different components. We can see that explicitly in scalar notation when we see that our resultant force, again, is equal to the sum of our forces, which is going to be equal to 3 components. So our resultant force in the x direction is equal to the sum of the forces in the x direction. We can say in the x direction like so. We can have the sum of the forces in the y direction for the resultant force in the y. And then the resultant component in the z direction is equal to the sum of the forces in the z direction. And remember, now our arrow is coming out of the board. So if we do x, y, z, our right-hand rule shows us the arrow coming out of the board in the z direction. Now, if I have a vector either in Cartesian vector notation with I, j, and k, or the same 3 components with their arrows, I can come up with their total by, again, using a modified version of the Pythagorean theorem. So when I have these equations worked out now, I can just double check my procedure regardless of methodology. My procedure is going to start by resolving my perpendicular components, typically into Cartesian vector notation, and then we'll sum our parallel components. How do you like that shorthand? Sum parallel components, so add up the x components, the y components, the z components. And then finally, I can express my 3D vector using the Pythagorean theorem to come up with the magnitude, and either using Cartesian vector notation or magnitude and unit vector, or magnitude and coordinate direction angle, or magnitude and transverse azimuth angle. And that's how we handle vector addition in 3 dimensions. It's exactly like in 2D, just expanded out. I look forward to working a problem with you in class. We'll see you then.